Hey everybody, welcome back to CSE 1322. This is module number 3, part 3. In today's class, we're going to talk about abstract classes. So let's go ahead and get started. You remember from the previous exercises and the previous lectures that inheritance gives you one major advantage, which is that you can reuse code that you've already written. You can take a parent class and you can make a child. That child is inherently going to get all of the behaviors or all of the methods and access to all of the attributes in the parent that are listed as public or protected. This allows you to not have to rewrite stuff over and over again, and it allows you to create hierarchies where you have information at the top that's propagated down to all of the children. So the problem that you'll run into here, and the reason for abstract classes, is sometimes when you're writing a parent class, you're going to realize that there's a need for a method, but you don't exactly know what the method does in the parent. Each child is going to do something slightly different. And that's going to be a case where you're going to use an abstract method. So let's take an example that we've seen before. So we have our mammals, and we had a mammal class at the top, and then we had a dog, a cow, and a cat underneath it. And each of those are children of the mammal class. So if we were to put methods into the mammal class, some of the things that we've put in there are like walk and, drink and so on and so forth. Well, we might want to put a talk or a speak method in there. And so then the question is, well, what does the mammal say? And the answer is that mammals don't really exist in the real world. There are dogs in the real world, and there are cats in the real world, and there are cows, but there are no mammal. It's not a real thing. It's an abstract idea of a type of creature. And so it doesn't make sense for us to really have a speak method or a talk method in mammal because it doesn't really say anything, because it doesn't really exist. But yet we know that all of the children of mammal are going to have a talk method, because dogs say woof and cats say meow and cows say moo. So we need something in there where we can put a method in mammal, but we don't really want to specify what we want the mammal to say. We want to leave the children to actually deal with that. And that's where we're going to deal with an abstract method. So pretty much all we're going to do is we're going to add the keyword abstract on front. And so this is the visual of what we were just talking about. You have your mammal up here at the top, and the mammal is allowing you to see all of the methods that it has. And it also has eat, drink, and move. So those are all real concrete methods. And then in addition, we have this abstract talk method. So by putting the word abstract here, it means we're not putting any details in mammal, and instead down in the children, in dog and cat and in cow, that's where we're actually going to write the real version of talk that has all the details in it. So let's take a look at the rules of abstract methods. So the first rule is that abstract methods are allowed to have parameters and a return type, just like every other method. So the header of an abstract method is identical to a regular method, except for the addition of the keyword abstract. But you can have 1 parameter, no parameters, 10 parameters, and all of the same rules that have been true for methods are still true. Likewise, for the return type, abstract methods can return a dog, a cat, they can return an integer, a float, a double, or whatever it is that you need them to return. The only rule is, once you say that the method is abstract, you are no longer allowed to have a body. And that means that the curly braces that usually surround the body of a method, they are now forbidden. You're not allowed to put curly braces in there. An abstract method means that your class is no longer complete. So if we go back to our mammal class over here, something to be aware of is that you can no longer use the mammal class to actually to instantiate an object. And that makes sense because it has this thing that isn't defined anymore, this talk method. And so effectively what we have is we have real methods here and here and here, but then we have an abstract method that does not have any content here. And so you can no longer instantiate mammal. Once you have a dog, a cat, and a cow, and you've actually created the talk methods in them, then you're welcome to instantiate them. You can instantiate dog, cat, and cow, but you can't instantiate mammal. Okay, so let's take a look at writing an abstract method for just a moment here. So what we're going to do is, as soon as that lets me jump out, we're going to zip over to IntelliJ, And what we're going to do is we're going to create a little bit of a video game here. So we're going to assume that our video game has some items. So I'm going to make a new Java class called item. And inside of that class, I'm going to have a couple of things. So I'm going to have a position, which keeps track of where we are. So probably an X position and a Y position that just tells us where on the board our item is. And then we're going to have a size, which tells us how big our item is. And we're going to have a Boolean, which keeps track of if the item is used or not. So think about in a game, you might have treasure chests, you might have keys, you might have potions, and some of them get to be used only once. And so we keep track of has it been used. All right, so this class is going to need some stuff, like we're going to need to get the size of the item. So we're going to need a getter. So we're going to do a public, and the size is going to be an int get size, and that's simply going to return the size. So this is a regular method, and right now this is a regular class. I haven't done anything new or anything weird yet. And likewise, we're going to do a getter on the is used. And so we're going to return is used there. Okay, so now we have the deal of how do we use this item. So we're going to need a public, we'll say it's a void right now, and it's going to be a use method. But the question is, well, how do we use an item? So again, the examples of this class that I gave you are, you might have a key, you might have a potion, you might have a treasure chest, and down the road, you certainly might have other items. So how do you use a key? Well, you have to be near a lock, and then you have to decide, is it the right key for that lock? How do you use a potion? Well, you just drink it, and it restores your health. So the use is going to be very different from each class to each class. So I'll go ahead and create the children classes. So I'm just going to do a new Java class, and this one's going to be key, and we're going to say it extends item. And likewise, I'm going to make the potion class, and it also extends item. And finally, we're going to make a treasure chest, just so that we have a little bit of variety. And it also extends item. Okay, so life is good, and I have in my parent class item this method use, but I don't actually want to write it. So what I'm going to do is I'm going to erase the curly braces, I'm going to put a semicolon at the end, and I'm going to add in the word abstract. So public abstract void use, or use, sorry. Now, the moment that I put this abstract keyword in here, a rule is that this class is no longer instantiable, because I have this weird method that doesn't have an actual meaning. So you can't make items, which makes sense because again in a game you don't pick up item, you pick up treasure chest or you pick up key. So we now need to mark this class as abstract as well. So you can have abstract methods and you can have abstract classes. Now, the moment that I do this, you see I now have three related problems, and those problems are coming from key, potion, and treasure chest. Because each of these say that they extend item, and it's okay for a concrete class, which is just a regular class like this, to extend a abstract class. But the rule is, when you do that, you must actually create a definition for any methods that were listed as abstract. So in order to make this work, I'm going to have a public, and it's not abstract in this version, void use, and the semicolon goes away, and it has to have actual parentheses or curly braces. And so in here in the key, I'm now going to write how to use a key. And again, that's probably figure out where the key is, figure out where the chest is, figure out if the key is the correct key for that chest, and then allow the user to insert the key into the chest, and then poof, the chest opens, or whatever it is that you're doing with the key. So now this is happy. If I go back to item, I no longer have three related problems, I have two, and that's because each of these has the same problem. So I have to have a public void use in each of these. What I put in that method is up to me, and it will change from item to item. Public void use, that's what it was called. And now all of my problems have gone away. Everything is no longer red, everything is no longer underlined. it is now valid. So again, I have an abstract method in an abstract class item. And then in each of the children, I have concrete versions of that method. And we've never used this word before because we never had an abstract method. So let me explain what I mean by abstract versus concrete. An abstract method has the word abstract in it, and it simply ends with a semicolon like this. A concrete method does not have the word abstract in it, and it has the set of curly braces, including the code for how to actually do that item. Every method you have written prior to this video has been a concrete method, because we had never seen abstract methods before. And likewise, every class that you had written was a concrete class, because we had not seen abstract classes. All right, so back over to our slideshow here just to talk through some of this. So abstract methods, they can have parameters, they can have return types. It has to be consistent from the parent to the child, just like in any other override. So if we ignore abstract for just a moment and we talk about the last section, we told you that you can write a method in the parent, and then in the child you can override that method. That's the same thing that's happening here with abstract. Implicitly, you're overriding the parent's method. Now, the parameters that you have to match. So if I go back over to my code for a moment and I take a look at this and I change it such that I say the use method is supposed to take in a, int time, which somehow tells you when you're allowed to use it. Well, now we're back to having three related problems again. All of these are no longer happy because the method that's declared in the parent has a parameter called time that is an integer. All of the children must also take in an integer as their first parameter. Now, they don't have to be called time, but they definitely have to have a first parameter that takes in an int. The signature of the methods always has to match between the parent and the children. That's true no matter whether we're dealing with abstract methods or whether we're dealing with concrete methods. And another point to put in here is that I am doing an override in all of these cases. So I really should have put the keyword override on front of each of these when I declared them. Now, it's kind of implicit in this case, but it's still a good idea to put it in there so that the compiler is completely clear on what you're doing and will tell you if you have an issue. The reason I say in this case it's kind of implicit is you're required to have a method called use. And if you forget to put that method in or you misspell it, then the compiler is going to kick it back anyway, regardless of whether you have the add override. So the add override is a little unnecessary in this case, but again, you should get in the habit of always just putting it in there. It makes it so that the compiler can check you. Okay, so if you have an abstract method inside of your class, that class can no longer be instantiated, and therefore the class must also be declared abstract. Okay, so the rules of an abstract class. Cannot be instantiated, that we've said before. The class header will have the word abstract in it. And then at least one method inside of the class may be abstract. Okay, now I'm saying that in a really weird way, and I'm going to do a whole slide on that in a moment. But usually the reason that the class is abstract is because you have an abstract method. But that doesn't actually always have to be the case. Sometimes you can have an abstract class that has no abstract methods. All right. Like other superclasses or like other classes, you can declare variables, you can implement methods, you can have constructors and toStrings. So if I go back over to my IntelliJ window here, you'll notice that in my item class, I had all of those things. I had I had attributes, those are all valid. I had other methods that were concrete. So the parent class is just a regular class. Even though I declared it as abstract, I can still do all the things I would normally do in a parent class. I probably also should have put in a constructor in here. So public item, and then whatever it is that I want to set in my, my constructor, like x position maybe is equal to 0, and the y position is maybe equal to 0 as well, and maybe the size is always 0 if you don't give me details. So I can have the regular constructor, I can have overloaded constructors. Everything that you can do in a regular class, you can do in a abstract class. And you might wonder, well, why am I doing constructors if I can never instantiate this class? Well, remember, no matter what, when you instantiate a child, it will fire the constructor in the parent first. So even though the parent is abstract and can't actually be created by itself, its constructor will fire when you create one of the children. So in this case, if I create an instance of key over in my main by doing something like key K1 equals new key, then implicitly what's going to happen here is the constructor in item is going to fire, and then the constructor in key, if there is one, is going to fire, and if there isn't one, it's going to write it for me. The same as has always been true. All right, so parent classes and child classes can have all the same things regardless of whether they are abstract or not abstract. The only other rule is that the child will be forced to implement all the abstract methods. If the child is declared as concrete, meaning it's not declared as abstract, then it has to have a concrete version of all the methods that the parent had. Okay, so abstract classes can have a mixture of methods which are abstract and concrete. And going back to my example with item over here, that was true here. These are all concrete methods. They actually have bodies. But this is an abstract method. It does not have a body. So there's a mixture of concrete and abstract in here. And the thing that's true is that you may have any combination of that. It could be that everything in here is abstract. It could be that only one thing in here is abstract. It could be that nothing in here is abstract. And all of that is valid in an abstract class. Concrete methods, they will always have a body. They'll have this curly braces with some code in it, whereas abstract methods are not allowed to have the body. The reason we're stressing this is a very common mistake people make is that they try to do this because they think that this still means that it has no body because they didn't put anything between the curly braces. But you can see the compiler is not happy with that. It literally cannot even have the curly braces. It must just simply end with a semicolon like that if it's abstract. All right. So, rules for the children. Typically, the child class of an abstract class will implement all the abstract methods it inherited. That's the whole point, is that the parent said there's going to be a use method. It's up to the child to implement that. So, pretty much all the children are going to implement it. The child can still access all the public and protected methods inherited from the parent. None of that has changed. It works exactly the same as before. If the child implements all of the abstract methods, then the child can be declared as a concrete class. However, it is also possible for the child to not implement all of them and for the child itself to also be abstract. So in this example, I just have two layers. I have the parent, which is item, and I have the child, which is key, potion, or treasure chest. But I could imagine a circumstance where maybe there's three different kinds of keys. There's golden keys and silver keys and bronze keys. And so we may have new classes that are children of key. So I'll create gold key, and it extends key. Okay, so once I do this, then gold key is probably going to be the concrete class, whereas key is now probably going to become an abstract class. Because again, it doesn't make sense for me, if I have three different kinds of keys, it doesn't make sense for me to just simply have a class key that has any kind of a meaning. So I have an abstract class key now, and I have a gold key, and I can certainly have a silver key and a bronze key, or whatever other combinations that I have. So remember that there's no rule that there can only be two layers here. There can be as many layers as you want. Now, if the child implements everything, which is the case for my key class, I have the option of making this abstract or not abstract. Because this has successfully created use, the method that we are required to create from the parent, key could be a concrete class. I could actually leave it as concrete. And then gold key can also be concrete. Everything seems completely reasonable there. Or I could decide that I don't want anybody to ever make a key, and so I'm just going to mark that as abstract. Now, I don't have to make it abstract because there's no rule that's forcing it to be abstract, but I may want to make it abstract because I don't want people instantiating key. I only want them to instantiate gold key and so on. So what happened here is item declared that there will be a use method. That use method got defined in key, and then gold key inherits from key the defined use method. So by the time we get to gold key, we're happy because we have a valid version of use key. Or sorry, use in this case. All right, so again, each child gets the option of implementing all of the methods that it inherited from above, in which case it becomes concrete. Or it can leave some of them out and leave it for the children, basically push the work off to the children. Sounds familiar? And the children will have to deal with the problem down the road, and they'll have to have their concrete versions. In that case, the parent can also be abstract. All right, so if at least one method remains abstract in a child, then the child must also be abstract. So again, any class that still has something that's abstract must be declared as abstract. So if we're getting to a concrete class, somewhere along the way, somebody has to implement everything. So picture a parent mammal, which is abstract. Let's imagine it has 4 abstract methods: eat, drink, move, and use hands. Then we have another abstract class which inherits from mammal called primates. So we have mammal, we have primates. Primates is a child of mammal, so it would inherit the rule that it has to implement all 4 of these. Well, it may choose to implement use hands because all primates have dexterous hands, but it may not choose to implement eat, drink, or move because that's different for each primate, how they eat, drink, and move. So in that case, the primate class would also be abstract. So you've got an abstract mammal, its child is an abstract primates, and then underneath it we have a concrete class called human, which inherits from primates and it implements eat, drink, and move. At this point, all 4 of the methods that were declared as abstract up in the parent have now been declared as concrete, and so human is instantiable. But you cannot make instances of primate or mammal for 2 reasons. One, they're not actually concrete, they don't have full definitions for everything. But 2, you don't walk down the street and say, oh, look, there's a primate. You might walk down the street and say, hey, there's a human. Again, in the real world, human exists, primate doesn't really exist. It's more of an idea. Abstract classes are more of an idea. All right, so to nail this one down, a common misunderstanding is it is true to say that if any method in a class is abstract, then the class must be marked abstract. That is a true statement. If there's at least one abstract method, the whole class has to be abstract. What a lot of people translate that into, which is not true, is that all abstract classes have at least one abstract method. And again, that's not true. You can create an abstract method class that has no abstract methods. That's perfectly valid. So an abstract class can have any number of abstract methods, including 0. A concrete class must have 0 abstract methods. All right, so if we take a look at creating our class or our objects, mammal M equals new mammal. In this example where mammal is an abstract class, this is not allowed because, again, it's an abstract class. But we can do polymorphism, and this is an important detail. I can say mammal M is equal to a new dog, mammal M is equal to a new cat, and mammal M is equal to a new cow. Presuming dog, cat, and cow are all concrete classes, then I'm allowed to instantiate each of them, and I'm actually allowed to put them on a variable of type mammal. All right, so let's talk through this for just a second. Mammal is abstract in this example, and it's the parent of dog, cat, and cow. I can still use it as a type, which is what's happening on the left-hand side. I'm declaring M to be of type mammal. And then on the right-hand side, I'm calling new on dog. So the rule with the new keyword is anything you call new on has to be instantiable. It has to be a concrete class. Since dog is a concrete class, I'm allowed to call new on it, and I'm allowed to store that on a mammal type. So all 3 of these are valid, and they are all examples of polymorphism here, where I'm using a parent class and instantiating a child class onto it. All right, once I've done that, my dog D is equal to new dog, I'm allowed to say d.eat. So that's because the eat method was declared in the parent, in this example, or it was declared in the dog. It doesn't really matter. All that matters is that this is a valid call as long as eat has been declared somewhere, whether it be in the parent or mammal or whether it be in the dog, the child. All right, so implementing polymorphism with an abstract class. If you're going to be creating variables of mammal, you're going to do mammal M. That means that the left-hand side of the equation, and I say left-hand side because usually there's an equals new something on the right, the left-hand side is a parent, so therefore on the right you can do new cat, new cow, new dog, all of those are fine. And then the interesting thing is you're allowed to call any method on the child which has been declared at the parent. So if you had an abstract make sound in the parent, then you'd be able to call that on all of the children. And what I mean by that is use is abstract here in my item class. If I am down in my main and I make a golden key and I make a treasure chest, and I call that, I guess, treasure chest 1, then I'm allowed to say key1.use, and I'm allowed to say treasure chest1.use. And I'm guaranteed that both of them have a definition for use, even though in the parent it was declared abstract. So how do I know in main that my golden key has a use method? Well, certainly I can go back and I can look and I can see it doesn't have one there, but it does have one there, so life is good. But I know that it's there because the parent has an abstract version of it. This effectively becomes a rule that all children of item, children, grandchildren, great-grandchildren, whatever, anybody who's instantiatable that is a child of item must have a use method. And this is the whole reason that we have abstract classes, and later when we talk in the next section about interfaces, it's there as well. It's because the person who writes the parent class is probably a different person than the person who writes the children. You, as a employee in a company, may be the person responsible for writing the dog, cat, and cow, but a whole other person may be the one who writes the mammal. So the person writing mammal can insist that you have a use method in all of your children by declaring an abstract method in mammal. And the reason that you might want to do that is because in the gameplay, there's a whole other team that's writing the gameplay. They don't have to care whether you implemented a use or not. They're guaranteed by the fact that you are a child of item that you have a use, because it's an abstract method in item. So if you are instantiable, you have a use. They don't have to worry about where that was defined or whatnot. That's up to you to figure all the details of that out. They just know it's there and it's usable. And that's really powerful because it allows you to call that method. All right, so let's look through this example. So we have an abstract class A, which has an abstract do things. And then we have a class B, which extends A, which is not abstract. And in this case, it has an override of do things. So we are allowed to make an object, A, my object equals new B. So the class A is used as the type of the variable, and the thing that we're instantiating is a new B, which is allowed because it's not abstract. And at this point, once I do that, I'm allowed to say my object, which is the name of my variable, dot do things, and I will get the overridden method here in B. It'll print out I do things 1 in B, which is a bit weird. I do things 1. Yeah, there probably shouldn't be a 1 there, but I do things in B. All right, moving on. The final thought, which I had mentioned before, is that there absolutely can be multiple layers in here. And in those multiple layers, it's a little hard to see it because of that, you can declare the abstract method all the way down until you actually want to deal with it. And this is not limited to 3. In this example, we're just showing you with 3. There could be 6 layers, 10 layers, 100 layers. It doesn't really matter. The only rule is that everyone's allowed to punt on it and say, I don't want to deal with talk until you get to the end. By the end, you must have an answer. Anyone along the way can declare it and do the work, but by the time you get to that very bottom of the tree down here at human, you better have an actual definition of talk, otherwise human is not instantiable. Okay, so that's the end of the lecture on abstract classes. The summary is abstract classes cannot be instantiated. They can have any number of abstract methods, which can include 0. If there is at least one abstract method, your class must be abstract. You can inherit from other abstract classes, and from there you can inherit abstract methods, which get passed down to your children as abstract, and then the child has to deal with it. Or you can inherit concrete methods, which just get passed down as concrete methods like they always have. Children, if they're going to be instantiable, can have no abstract methods, and polymorphism works the same way here as it did in the last section, where you can have children that are instantiated on top of a parent type at any level of the tree. You could have a grandparent that has a child on it, and that's all perfectly allowed. So that's the end of abstract classes. In the next section, we're going to talk about interfaces, which are kind of similar to abstract classes. I'll see you guys there.